Hello all, I am Dr. Prabhas Sanjanwal. In today's class, we'll discuss about some undecidability problems. Okay, so there are a lot of undecidability problems. Now we'll discuss what are the meanings of undecidability problems and which problems are called undecidable. Okay, so the first problem we'll see the first problem. Halting problem of Turing machine. Halting problem of Turing machine is decidable or undecidable. The first point, see, by read what is the meaning of first we'll see what is the meaning of halting problem of Turing machine. By reading the string x, by reading the string x, whether by reading the string x, whether the Turing machine halts or not. By reading the string x, whether the Turing machine halts or not, this problem is called as halting problem of Turing machine. Okay, so this problem is decidable or undecidable. Okay, so next we'll see the next one. This problem is decidable. This problem is decidable for recursive language and undecidable for recursive enumerable language. Okay, so halting problem of Turing machine is decidable for recursive language and undecidable for RL language. Okay, so the next point, hence halting problem of Turing machine is undecidable. If someone asks me halting problem of Turing machine is decidable or undecidable, by default halting problem of Turing machine is undecidable. Why? Because this problem is decidable for recursive language and undecidable under RL language, means recursive enumerable language. But by default language is called recursive enumerable language. See in the next point here, by default Turing machine means REL Turing machine, means recursive enumerable language Turing machine, or we can say that this is called as the halting Turing machine. Okay, so finally halting problem of Turing machine is undecidable. Halting problem of Turing machine is undecidable. Okay, but if we'll expand halting problem of Turing machine, this problem is means the halting problem of Turing machine is decidable under recursive language and undecidable under REL language or recursive enumerable language. But in normal we can say that halting problem of Turing machine is undecidable. Okay, next we'll see the next undecidability problem. See the next problem, second problem, intersection empty problem. What is the meaning of intersection empty problem? In we can also write like this: L1 intersection L2, L1 intersection L2 equals to empty or not, or phi or not. This is a question mark. L1 intersection L2 equals to phi or not. Okay, so what is the meaning of intersection empty problem? Checking whether intersection of two given languages empty or not. Checking whether intersection of two given languages empty or not. This is called intersection empty problem. Okay, checking whether the intersection of two given languages empty or not. So now we'll see this problem is decidable or undecidable. Okay, see this problem means intersection empty problem is decidable under regular language and undecidable under remaining languages. Remaining languages means suppose context-free language, DCFL language, okay, recursive language, CSL language, REL language, like this. So this problem is decidable under regular language but undecidable under the remaining languages. This is called intersection empty problem. Okay, we have also given a chat on all undecidability problems. Okay, later we'll see. So the next one, The next undecidability problem is called totality problem. Totality problem, or we can say completeness problem. Totality problem or completeness problem is, in short, we can write like this: is L equals to summation star or not? Okay, we can also write like this: the totality problem or completeness problem. Checking whether the given language, checking whether the given language is complete language or not. Checking whether the given language is complete language or not. This is called totality problem or completeness problem. Okay, so this problem is decidable or undecidable. See, this problem is decidable. This problem is decidable under regular language and disabled language. This problem is decidable under, this problem is totality problem or completeness problem. This problem is decidable under regular language and disabled. Disabled means deterministic context-free language, and undecidable under remaining languages. Remaining languages means context-free language, like recursive language, CSL language, REL language, like this. Okay, so these are called like the totality problem or completeness problem. Next, we'll see subset problem. What is the meaning of subset problem? Subset, in short, we can write like this: is L1 is the subset of, L1 means L1 is a language. Is L1 is the subset of L2 language or not? Is language L1 is the subset of language L2 or not? This is called a subset problem. Checking whether the language L1 is the subset of language L2 or not. Checking whether the language L1 is the subset of language L2 or not. Okay, this is called a subset problem. Next problem. Now next point. Now we'll see this problem is decidable or undecidable. Say this problem is decidable. This problem is decidable under regular language. This problem is decidable under regular language and undecidable under remaining languages. Remaining languages means similarly CFL language, disabled language, CSL language, recursive language, and REL language, like this. Okay, so these are some undecidability problems. Okay, now we'll see the next undecidability problem. Okay, the next undecidability problem is complement of a language, is complement of a language the language of same type or not? Is complement of a language the language of same type or not? Okay, so this one is decidable or undecidable. Okay, later we'll see is complement of a language is language of same type or not. Complement of a language is language same type or not. Later we'll see. The next problem is intersection of two languages language of same type or not. Is intersection of two problems language of same type or not? Okay, so these problems are decidable problem or undecidable problem. Later we'll see. See, this is one important chart. This is one important chart. This charts I have just given. Okay, the first problem is, this is called emptiness problem. This is called emptiness problem. Emptiness problem. This problem is called as emptiness problem. Okay, emptiness problem, we have already, what is the meaning of emptiness problem? We have already discussed in the previous classes. You can see what is the meaning of emptiness problem. Okay, so the emptiness problem is decidable or undecidable. See, the emptiness problem is decidable under regular language, decidable under disabled language, decidable under CFL means context free language, undecidable under CSL means context sensitive language, undecidable under recursive language, undecidable under REL language or recursive enumerable language. This is called emptiness problem. We have already discussed about the emptiness problem in the previous classes. Okay. So the next problem. This problem is called as finiteness problem. Finiteness problem. Okay. Is L is finite or not? We have also discussed about the finiteness problems in the previous classes, means decision properties of regular and context-free language. We have already discussed. Okay. So now we'll see the finiteness problem is decidable or undecidable. Okay, see, the finiteness problem is decidable under regular language, decidable under DSFL language, decidable under CFL language, undecidability under CSL language, undecidability under recursive language, undecidability under REL language. Okay. So the next point, is W belongs to L or not? Is W belongs to L or not? This problem is called as membership problem. Membership problem. This problem is called as membership problem. So the membership problem, we have also discussed the membership problem in decision properties of regular and context-free languages. Okay. So the membership problem is decidable or undecidable. The membership problem is decidable under regular language, decidable under DSFL language, decidable under CFL language, decidable under CSL language, decidable under recursive language, undecidability under REL language. Okay. So the next problem we'll see, is L1 equals to L2 or not? This is called equivalence problem. Equivalence problem. Equivalence problem is decidable or undecidable. This problem, equivalence problem, we have also discussed about the equivalence problem in decision properties of regular and context-free language also. So the equivalence problem is decidable under regular language, undecidability under DCFL language, undecidable under CFL language, undecidable under CSL language, undecidable under recursive language, undecidable under REL language. Okay. Next we'll see the fifth one. Is L1 intersection L2 equal to 5 or not? This is called intersection empty problem. This problem we have already discussed. Intersection empty problem. See this problem. Okay. This problem. Okay. So see, the intersection empty problem is decidable under regular language, undecidable under DSFL language, undecidable under CFL language, undecidable under CSL language, undecidable under recursive language, undecidable under REL language. This is called intersection empty language. Okay. So next we'll see next problem, the sixth one. This is called as totality problem. Totality problem. Totality problem or completeness problem. We have also discussed this problem, totality or completeness problem. See, this problem, totality or completeness problem. Okay. See, the totality or completeness problem. What is the meaning of totality and completeness problem? We have already discussed. So now we'll see this problem is decidable or undecidable. This problem is decidable under regular language, decidable under DSFL language, undecidable under CFL language, undecidable under CSL language, undecidable under recursive language, undecidable under REL language. Okay. Next we'll see the subset problem. Subset problem. See, subset problem is also, we have also discussed about the subset, this problem, subset problem. Okay. So we'll see here. The subset problem is decidable under regular language, undecidable under DSFL language, undecidable under CFL language, undecidable under CSL language, undecidable under REC language, undecidable under REL language. This is called as subset problem. The next problem, eighth one, language is a given language is regular or not? Is a given language is regular or not? Okay. So suppose a language is given, now we'll say that this language is regular or not. So this problem is decidable or undecidable. See, this problem is decidable under regular language, decidable under DSFL language, undecidable under CFL language, undecidable under CSL language, undecidable under recursive language, undecidable under REL language. This is called as a language is regular or not. Okay. Next we'll see. The ninth one, each complement of a language is same type or not. So this problem you can see, we have also discussed about this problem, this one, ninth one, a problem. Is complement of a language of same type or not? This problem is decidable or undecidable. Ninth one. Okay. So we'll see. So this problem is decidable under regular language, decidable under DCFL language, undecidable under CFL language. Because there is a question mark means we don't till that means we don't find the solution. This problem is decidable or undecidable under CSL language. So decidable under recursive language, undecidable under REL language. So the next problem, 10th one, each intersection of two languages produces same types of language or not? Means this problem you can see, we have also discussed about this problem. This problem, 10th one, each intersection of two languages, language of same type or not? Each intersection of two languages, language of same type or not? Okay. So 10th one, each intersection of two languages, language of same type or not? Decidable under regular language, undecidable under DCFL language, undecidable under CFL language, decidable under CSL language, decidable under recursive language, decidable under REL language. Okay. So these are the chat of some decidability and undecidability problems. Okay. So we have also discussed some undecidability problems. These are some undecidability problems you can see. See, one problem is called a state entry problem. The state entry problem is decidable or undecidable. Okay. See, the state entry problem is completely undecidable. The state entry problem is undecidable. Okay. Some examples of state entry problem is here. Language L1 equal to MQ. M means a Turing machine. M means a Turing machine. M visits the state Q. M means Turing machine. Q means the states. Turing machine M visits the state Q on some inputs. Because we don't know on which input the Turing machine M will visit the state Q. So this problem is undecidable. Next example, see the language L2 MQ, Turing machine M visits the state Q on some inputs within 10 steps. Because here means then which means how many steps the Turing machine will visit the state queue. Completely defined. So this problem is called as decidable. But here the how many steps we don't know. So that's why this problem is undecidable, and that's why this problem is decidable. But anyway, the state entry problem is undecidable. The state entry problem is undecidable if some steps or something is given. If something is given like within the 10 steps it will visit, the machine will visit. So this problem is decidable. Okay, so these are called as state entry problem. See, the next problem, does a given program ever produces an output? Does a given program ever produces an output? This problem is decidable or undecidable. Remember, this problem is undecidable. Does a given program ever produces an output or not? This problem is undecidable. Okay. The next problem, checking whether the two given programs produces same output or not. Checking whether the given two programs produces the same output or not, this problem is completely undecidable. This problem is undecidable. So both problems are undecidable. Does a given program ever produces an output? This is undecidable. And checking whether the two given programs produces the same output or not, this problem is also undecidable. Okay. So the next concept, partially decidable or semi-decidable. What is the meaning of partial decidable and or we can say semi-decidable? See the definition. If a program or problem, we can say, if a problem is decidable under recursive language, if a problem, here we can write program, or we can write problem. If a problem is decidable under recursive language, and undecidable under REL language. REL language means recursive enumerable language. So if a problem is decidable under recursive language and undecidable under REL language or recursive enumerable language, then this problem is said to be partial decidable or semi-decidable. Okay. So if a problem is decidable under recursive language and undecidable under REL language, then this problem is said to be, or we can say this problem is called as partially decidable or semi-decidable. Okay, so this is the end of today's class, and in the next class we'll see about the modifications of Turing machine. Okay, thanks for watching.